Site selection when it comes to placing the probe is absolutely critical. Considering this probe is going to help you in making very important management decisions, it's critical that it's located in the optimum place. So what we do is we can look at a few tools we can use. We can use remote sensing, plant cell density, which shows us the health of the canopy, and that is directly influenced by the soil types. We can do EM surveys, which basically is an electromagnetic signal which determines clay and sand. And then we can use topography, such as aspect, slope, and watershed boundaries. So I'll take you through the steps that we used in this application. So first off, we took the vineyard, like a blank canvas. That's just the image of the vineyard with no information on it. Then on top of this, we put a surface map of plant cell density. And what that's done is basically applied the values of the vine by vine information, but as a surface map to give us total area. In this particular area, the dark blue area is a high vigot, the red area is a low vigot. In both cases, these are places you don't want probes. So what we do is we remove the top and bottom 5% and we mask it off. So what we've done basically is removed all the extremes. Next, what we do is we bring in aspect. North facing aspects are hotter. Their soils are usually quite different. You know, we're talking millions of years of hotter, longer days as compared to the southerly aspects, which are cool. So what we're doing here is we're removing the extremes, or the aspects which aren't representative of the block. So the really cool southerly aspects and the really hot northerly aspects. Then we mask these out. Next we go into soil-based factors. Now this is clay soils versus sandy soils. Now in this example here, yellow is sandy soils and the dark brown areas, that's the heavy clays. This is not an absolute, but it is a very good guide to where the lighter soils and the heavier soils are. Keep in mind, soil moisture can affect this a bit too, so it's best to do it at a dry time of the year. And like the previous two, we remove the extremes, which is the really deep sands and the really heavy clays. We then remove these from the scenario. Then we bring all the no-go zones back. Plant cell density, the aspects, the EM soil survey, and what we've created now is the same vineyard but with a range of no-go zones. As you can see, if you ended up putting a probe sort of in one of these areas with two factors that didn't make it a representative block, that information could or would lead to making incorrect management decisions. Anyway, finally, just as an added benefit, you can look at watershed boundaries. So this line here determines any rain that falls on that side drains to that side, anything that falls on this side drains to that side. So two different watershed boundaries. In the optimum situation, you're likely to put a probe each side and that'd be two separate irrigation sections. In this case it was a single irrigation section, so we chose that location for the soil moisture probe. Now when you started getting information from that soil moisture probe, then any management decisions made will benefit the block as a whole, not sort of indiscriminate sections of the block. That's site selection.